In our section 2.3, we're going to review lines. We're going to talk about first graphing lines, and then we're going to talk about finding equations of lines. So let's get started. And when we start our discussion of graphing lines, we need to start with a discussion of slope. And the slope of a line is really just its steepness. The French mathematician René Descartes is the mathematician that came up with the idea of slope, and because he was French, he used the word monter, which means to climb. So as a nod to Mr. Descartes, we frequently use the letter M to denote the slope of a line. And if you have 2 points, let's say x1 and y1 and x2 and y2, the slope, we use the phrase often rise over run to describe how steep something is, how high does it climb, and in what horizontal distance does it do that, rise over run. And the formula that we can use, if we have our ordered pairs labeled like this, is the formula y2 minus y1 over x2 minus x1. Okay, so for example, for this line right here, I'll go to green so that you can tell it apart. But this example right here, if you were to find the slope between these 2 points, you would have, let's see, these points are x is 0 and y is -1. And x is 1, 2, 3, and y is 1. So if we're finding the slope between those points, we could call, like we've labeled, x1, y1, 0 and -1, and x2, y2, 3 and 1. So our y2 minus y1 could be 1 minus -1, and x2 minus x1 could be 3 minus 0. Just make sure that when you're doing this, if you start with the y2 of 1 in the top, you start with his partner 3 for the x's in the denominator. Okay, simplifying, we get 1 minus -1 is 2 over 3, so we have a slope of 2/3, which means we would travel up 2 and over, or to the right, 3. Before we do some examples, there's one more aspect of lines that we need to discuss, and those are the x and y intercepts. So let's take a look at these for this line here. Taking a look at the x-intercept, that's whenever our graph touches the x-axis. So this would be the x-intercept. And what I want you to notice about the x-intercept is, depending on where your line is, that x-intercept could be anywhere, but it has to be touching the x-axis. If it's touching the x-axis, then there can only be one possible y value. Y has to be equal to 0 at the x-intercept. So at the x-intercept, we have to have y is equal to 0, always. Likewise, at the y-intercept, which would be here, the x value is always equal to 0 because you're always on top of the y-axis if you're talking about the y-intercept. So then in that case, the left-right value, or the x value, has to be 0. So for the y-intercept, x is equal to 0, always. Okay, so let's use this information to talk about a quick way to graph lines. and that is using the slope-intercept form. Y equals mx plus b, where m is the slope of the line, and b, or more specifically, x equals 0 and y equals b, is the y-intercept of the line. So, for example, if we had to graph, let's say y equals negative 5/2 x plus 2. It's already in the slope-intercept form. I just need a grid. There we go. So when we're graphing using the slope-intercept form, you always want to start with the y-intercept, which would be, in this case, 0, 2. So here is x equals 0, y equals 2. There we go. So here's our 0, 2. And then the slope of this line is negative 5/2. So we're going to, because it's negative, go down 5 and then to the right 2, or over 2. So from there, from the 0, 2, we go down 1, 2, 3, 4, 5, and over 2 to the right. And we have our next point. In connecting those 2 points as best we can, we have a picture of our line. Okay, one quick thing I want to point out, because I have the time. If you want to put the negative instead of with the top, so that it goes, and with the numerator, so that it goes up instead of down for some reason, you're welcome to go up 5, and then instead of going to the right, go left 2. And if you look at this, 1, 2, 3, 4, 5, and the left 2, so left 2 and up 5 will also get you on that same line. So the negative in front of the slope can either be applied to the numerator, making the graph go down, or to the denominator, making the graph go to the left. What you cannot do is don't apply it to both. So notice if you went down 1, 2, 3, 4, 5, and to the left 2, you're way off your line. Okay, let's do one more of these before we move on to something harder. So for our next example, let's graph 3x minus 2y equals 8, stating the slope and the y-intercept, which is important to point out because 3x minus 2y equals 8 is not in the form y equals mx plus b that would tell us the slope and the y-intercept. So we need to get it in that form. So 3x minus 2y equals 8, we're going to isolate the y. Okay, subtract 3x over negative 2y equals negative 3x plus 8. And I'm careful to write the x in the front so that it lines up with the mx from this form. Then divide everything by negative 2. And we have y equals, let's see, negative 3x over negative 2 just simplifies to positive 3 over 2x. But 8 over negative 2 makes a negative 4. So our slope is positive 3 over 2, and our y-intercept is 0, negative 4. So we're going to start at 0, negative 4. 1, 2, 3, 4. And we're going to travel up 3 and to the right 2. 1, 2, 3, 1, 2. And then draw in our line. And notice if we happened to go instead, make both of these negative, down 3 and to the left 2. 1, 2, 3. And to the left 2, we would still end up on our line. Great, let's do something different. For our last graphing using y equals mx plus b, let's graph the line 5x equals 2y. Well, this is definitely not in the format that we want it in, so for starters, we can write this as 2y equals 5x with no problem. And then getting the y totally isolated, we'll divide both sides by 2. So while we have a lot of simplifying on the left side with just y equals now, 5x over 2 doesn't simplify, so we'll write that as 5 over 2 times x. And this is what we'll graph. Okay, and I can tell by looking that clearly the slope is 5 over 2, meaning we're going to travel up 5 and over, or to the right 2. What I don't see is the y-intercept, but if it's not written in, it's supposed to be 0, plus 0. So our y-intercept is going to be 0, 0. Okay, that's always where we start, and it's unusual to start right in the middle, but we do in this one. We start at 0, 0, and then we'll travel from there up 1, 2, 3, 4, 5, and over 1, 2, and draw the line connecting them. Now we'll finish our discussion of graphing lines with graphing certain types of lines. So let's take a look. So we're going to graph in this part of the lesson horizontal and vertical lines. Horizontal and vertical lines are kind of easy to recognize that they don't fit into the previous section, because if we were to graph something, say we were to graph x equals -2. It clearly doesn't fit into our y equals mx plus b category because it doesn't have any y's in it. So bear with me in red while I explain how this graph makes this equation makes the graph that it does. So I'm going to do this by picking some ordered pairs. I'm going to make the x's are stuck apparently at -2, so all of the x values I'm going to pick have to be x equals -2 because that's the equation. Now for picking the y's, I must be able to pick y to be any number I want. There isn't even a y in the problem. So how about we pick y equals 3 and 0 and -1. And when we go to plot these points, we've got x is -2 and y is 3. X is -2 and y is 0. And x is -2 and y is -1. So clearly we have a vertical line. Now I'd like you to be able to do that more quickly than I just did. So let's do another example. And in order to save time and to do some comparison, I'm going to put this example in green, but on the same axes. So let's graph x equals 1. Okay, well, just like x equals -2, this should be the same kind of line. Since x equals -2 was a vertical line, then x equals 1 should be a vertical line, and it should go through all x equals -2 points. So this one should go through all x equals 1 points, and we get our line. Done. Now I want to explain just a little bit what's going on. X equals 1 is a vertical line because the x values are all fixed at 1. However, the y values, since they're not listed, can vary. They can be anything they want to. So our left-right values, our x values, are fixed at 1, but the up-down values, the y values, aren't even listed. They can be whatever they want to. So finally, if we did one last example and say we were to graph in yellow y plus 7 equals 0, this is going to be a horizontal line, y equals -7. So what I do when I graph these is I isolate the variable, say x equals 1 or y equals -7, 1, 2, 3, 4, 5, 6, 7. There's y equals -7. And I draw a line through that axis. So if I have a y equals equation, my line goes through, I should have labeled this, the y axis. If I have an x equals, like x equals 1, the line goes through the x axis. One final thing to note about horizontal and vertical lines is their slope. So if you look at the slope of a horizontal line and you think of rise over run, or you think of the steepness of a hill, there is a zero slope, there is zero hill on a horizontal line. So for a horizontal line, the slope is always 0. For vertical lines, man, that is the steepest you could possibly get, correct? For a vertical line. And if you were to verify it, say you were to find over here between any 2 points, -2, 3 and -2, 0, and you were to find the slope between those 2 points, maybe doing 3 minus 0 and -2 minus -2, you would get 3 in the numerator, but you would get 0 in the denominator, which is undefined. So for vertical lines, they are our lines that have undefined slope. I'd love to say infinite slope because the slope is infinitely large, but we say undefined slope. Horizontal lines do have a slope, it's just 0. We'll finish our discussion of lines with finding equations of lines. And I already discussed one of the formulas that I'd like you to use when you're finding slope at the beginning. I'll write that down in a second. But the main equation I want you to use when you're finding equations of lines is what we call the point slope form of a line. Let me write that down. So the point slope form of a line finds the equation of a line given one point, namely x1, y1, and the slope, m. Now, I'm not going to do an example where I give you all that information. I'm going to treat you like this is a review. So our first example will look like this. Find the equation of the line that passes through the ordered pairs -4, 2, and 3, 7. You do need to know one other equation that we talked about at the beginning of this video. You do need to remember that the formula for slope is y2 minus y1 over x2 minus x1. Okay, so when we find the equation of the line through these points, the first thing you want to do is write down your y minus y1 equals m times x minus x1. It's your starting place, and it's also what we're going to plug everything into. The second thing you want to do right away is always find your slope. In this case, because we have two ordered pairs, we're going to use our formula up here to find the slope. So we're going to do m equals, label them however you want to, but I think it makes the most sense to have the x1, y1 be the first point, -4 and then 2, and the x2, y2 be 3 and 7 respectively. So y2 minus y1 would be 7 minus 2. And if we start with the 7 in the numerator for the y's, now we must start with the 3 in the denominator for the x's. 3 minus -4. And if it's an extra negative, I'm going to put parentheses around it. Oh, so what we get is a rather ugly slope, 5/7. Okay, there's our slope. And then our third step is going to be to plug, I'm going to scooch things up a sec. Plug m and x1, y1 into the point slope formula. Okay, so let's see, y minus y1 equals m times the quantity x minus x1 becomes y minus 2 equals m is 5/7 times the quantity x minus x1, so plus 4. Great. Now, incidentally, the x1 and the y1 here actually do not have to be exactly the same x1 and y1 here. So if you put y minus 7 equals 5/7 times the quantity x minus 3, you should still get the same answer at the end. Okay, so let's finish getting this in y equals mx plus b format. Distribute the 5/7 through, maybe making the x and the 4/1, both of them. So we have y minus 2 equals 5/7 x plus 20/7. And then adding 2 to both sides, 5/7 x plus 20/7 plus 2, which would be like terms with the 20/7 if I multiplied the top by 7 and the bottom by 7, I could get common denominators. So now I have y equals 5/7 x plus 20/7 plus 14/7 gives y equals 5/7 x plus 34/7. Lovely. Okay, let's do one that's a little bit different than this. So to finish our discussion on finding equations of lines, we need to discuss the slopes of lines that are parallel and the slopes of lines that are perpendicular. So looking at our two parallel lines here on the left-hand side, I'm going to label the top line having slope m1 and the bottom line having slope m2. And if we think of slope as steepness, then parallel lines have the same slope. So m1 equals m2. On the other hand, perpendicular lines. So remember, a perpendicular line, two perpendicular lines mean they make a right angle with each other. And what I'd like you to notice about the two perpendicular lines that we have graphed here is the first one that's green is going up and to the right. So if I call his slope m1, that would be a positive slope because it's going up. On the other hand, m2 for the other line, the blue line, is going down. That would be a negative number. We call those, in mathematics, we call those opposites. So perpendicular lines have opposite, meaning one's positive and one's negative, and reciprocal slopes. What that means is, in mathematics, m1 equals negative 1 over m2. But as a quick example in here, say you had a slope that was equal to 5/3. Then a slope that is parallel, a line that is parallel to that would have the slope 5/3. But a line that is perpendicular would have a slope that is negative, the opposite, reciprocal 3/5. Let's practice this when we're finding equations of lines. So remember, parallel lines will have the same slope and perpendicular lines will have opposite reciprocal slopes. So you change their sign and then you flip their fraction. In this example, we'll find the equation of the line that passes through the point -3, 2, and is perpendicular to the line 2x minus 3y equals 9. So the first thing that we want to do is start with our general equation, point slope form of a line, y minus y1 equals m times the quantity x minus x1. And right away, we want to find the slope. Okay, in this problem, we can't use the formula y minus y1 over y2 minus y1 over x2 minus x1 because we only have one ordered pair. But we do know that our line is perpendicular to this line, 2x minus 3y equals 9. So to find the slope of this line, we need to isolate the y. So negative 3y equals negative 2x plus 9. And then dividing by negative 3, I'll write that in, negative 3, negative 3, negative 3. We get y equals positive 2/3 x minus 3. But now remember, this line is perpendicular to our line. So if this slope is positive 2/3, that means that our slope is negative 3/2, the opposite reciprocal. And now we can plug our ordered pair, negative 3, 2, and our slope into step 1. So y minus 2 equals negative 3/2 times x minus negative 3 makes it x plus 3. And I will highlight the slope that we got from step 2. Perfect. Y minus 2 equals negative 3/2 times the quantity x plus 3. Now, generally, we are probably going to have to give our answer in slope-intercept form. So step number 4 will be isolate y. So y minus 2 equals negative 3/2 x minus 9/2. And then when we add 2 to both sides, y equals negative 3/2 x minus 9/2 plus 2. Multiplying top and bottom of that 2 by another 2 to make it a common denominator of 4, we have y equals negative 3/2 x minus 9/2 plus 4/2. So our answer is y equals negative 3/2 x minus 5/2. The equation of the line that is perpendicular to this line in red, y equals 2/3 x minus 3, and it passes through the ordered pair negative 3, 2.